Alright guys, today I am at the McKinney Art Museum and we're going to talk about dimensional analysis today. So let's go ahead and get started. Alright, so last time in class we played the domino game, and some of you guys were probably wondering what that has to do with chemistry and why we did that. Well, it has to do with this, dimensional analysis. And I know it sounds like something crazy, but it's really just a way to convert units from one unit into a different one. And we're going to do this a lot this year because units are super important, just like sig figs. In this class, anytime you get a number, it's not an answer until it has the right number of sig figs and the correct units. So dimensional analysis will help you convert units from the kind you have into the kind you want. So for example, let's look at this problem up here. I want to know how many seconds there are in 12 years. All right? So we can actually solve this problem by following the rules of the domino game, believe it or not. Let's go ahead and get started on that. So, the first and most important thing to do when you're doing this kind of problem is to set it up properly. And if you remember, the rules for the domino game are, we're going to start by putting down or writing down the domino that we're looking for first. Okay, so I'm actually going to take this question mark seconds up here, and I'm gonna look at it like a domino with a blank bottom. Just like in the domino game, you sometimes had dominoes with a blank bottom. That's the one that I'm looking for, okay? And throughout this whole process, you're not looking at the numbers. All you're looking at is the units. So the units is what we're gonna use like our dominoes from the domino game. So let's set this up, right? So first thing I'm gonna do is write down question mark seconds. I'm gonna abbreviate it second, and that's got a blank bottom, right? Then I put my equal sign, and if you remember back to the domino game rules, the first domino you put after the starting domino has to match the bottom, right? So I need the bottom of my next domino down here to match whatever's on bottom of the starting domino. And we can see that that's blank, okay? So we need a domino that has a blank bottom to go after our equal sign. And if we look up here at the top, my 12 years domino also has a blank bottom, so it matches straight across. So I'm going to write that one down first. So I have 12 years, and I'm just going to abbreviate that YR, okay? So we have the domino problem set up now, and that's really the most important part. If you get this step right here, setting it up properly, everything else will be a lot easier from this point forward. Now what we have to do is start adding dominoes to this thing that we have here. And I'm going to go ahead and put some dominoes on the screen, and we'll put them onto the domino game and line them all up properly according to those same rules. Okay guys, so I had to make myself a little smaller up here in the corner because I need the room for all these dominoes. But I just rewrote everything, and I have up here in the top left of the screen a whole bunch of dominoes that we can use in this problem, okay? So this is like your hand of dominoes from the domino game. And if you remember, the rule is for playing a domino, what has to match is the top of the current domino has to match the bottom of the next domino, okay? So what I'm going to do here real quick is just extend this line all the way out over here. And then every time I add a new domino, I'm just going to put a line between it and the previous one like this, okay? So if we look here, what I need to match here is not the 12. I don't care about the 12. I want to match years from the top of this domino to the bottom of that domino. And I can pick any of the ones that I have up here, right? So you can see that only one domino, this one here, has years in it. And that's the one I'm going to use. But when I put it into the problem, I need to make sure it follows the rules of the domino game, right? And that means that the years on that domino have to be on the bottom. But they're not on the bottom right now. They're on the top, right? They're on the top up here at the top of years. But that's okay, right? Because remember in the domino game when that happened, all you had to do was flip the domino upside down. That's it. So if we want to use this domino, we can. And we want to use it because it has years in it. All we have to do is flip it upside down when we put it in. So let's take the domino from up there and write it into our problem. We want the years, so 1 year is going to be down here because it wants to match down and across. And then on top, we'll put the rest of that domino, which was 365 days. And then I got this domino written, so I'm just going to go ahead and draw a straight line down like this, okay? So what we have now are two dominoes set up, and the key thing is they match down and across, diagonally like this. So the top of this domino over here matches the bottom of this domino over here, right? And all you have to do is just keep doing this over and over and over again until you win the game. Okay, so let's add another one, right? So the next one, what does it have to have on bottom? Well, again, it has to match down and across, right? So the units on this one is days. I'm going to pick a domino up here that has days in it, which is, you can see this one right here has days in it. And the days is already on bottom, so I don't have to flip this one, right? So when I put it in, I just want to make sure that it's lined up properly. I have 365 days on this domino. This domino, I want to put in 1 day on the bottom. And on top, I'm going to put the rest of that domino, which was 24 hours. And I'm going to draw a line because I finished that domino, okay? So what's the next one? Yeah, so I need hours to match from top to bottom, right? The domino that has hours in it is this one up here, 60 minutes and 1 hour. So I'm going to put that one in with the hour on bottom, 1 hour on bottom, and the rest of that domino, 60 minutes on top. Okay, and draw a line, so I finished that domino. And I'm still adding dominoes because remember, the way you know you won the game is when the unit in the top of the domino that you started with matches the top of this last domino over here. So we're not quite there yet. We need to add at least one more domino, okay? So what does that next domino have to have on bottom? It has to match. Remember, this unit on top has to match on bottom. This domino here has minutes in it. We have to flip it, which is okay. So I'm going to flip it so it has 1 minute on bottom and 60 seconds on top. Okay, so now, if we look, this unit, not the number, but the unit here, seconds, matches with what we started with in the top of the starting domino, which means that we're done adding dominoes and we've won the game, right? So we win, and that's where we stopped in the domino game, but there's one extra step when you're doing dimensional analysis. Okay, guys, so just to review, the problem is set up properly. We know it's set up properly because first and most importantly, we started off right because the bottom of our starting question domino matches the bottom of the first domino, okay? So this one matches straight across, and then every other domino in the game matches top to bottom, top to bottom, top to bottom, top to bottom. We know we finished adding dominoes because the last top domino over here matches the starting top domino in our question. Okay, that's how we know we're done adding dominoes. It's really important you guys know not only how to start bottoms match, how to add dominoes down and across, down and across, down and across, but also how to know when you're finished adding dominoes. So we know we're finished because the top domino here matches the top starting domino. And you guys know all this from the game, so it's no different there. So how is this different from the game? Well, the last step is to actually get an answer. And to do that, we need to do some math, okay? So you can always use your calculator, which I have out here. I'm using my phone for my calculator, but you guys should use the actual calculators in the classroom, if you're in the classroom, so I can see your work. But to get an answer here, it's actually really easy. It's no big deal. All you're going to do is take all the numbers on the top, so all these numbers here, and just multiply them by each other, okay? So it's just going to be 12 times 365 times 24 times 60 times 60. Just type all that in, and when I do that, the answer I get is huge. It's a huge number. It's 378,432,000. Which makes sense, right? Because that's 12 years should have a lot of seconds in it. Okay, so that's a really big number. So that's the number we get from the top here. Then we're going to do the same thing to the bottom numbers. Okay, so all these numbers on bottom, we're just going to multiply them by each other. And this one's really easy because 1 times 1 times 1 times 1 is just 1, right? So we do that same thing. Put it on the bottom, okay? So we have the top number that we got from multiplying the top numbers by each other, and the bottom number we got from multiplying the bottom numbers by each other. And the very last step here is just to actually do this division, just like it looks like. It's a fraction, right? We're going to actually divide this. So 378,432,000 divided by 1. And of course, anything divided by 1 is the same number, so this just simplifies to the same number. 378,432,000. Now, that is a number. But in chemistry, that's not an answer, because it's missing two things. And we're going to do this on every single number you give me this year. It needs to have the right units, which is why we did this whole crazy thing to get the right units, and the right number of sig figs. Okay, so what are the units going to be? Well, the units should be the units that we were looking for, right? It should be these units over here. That's why we did this whole thing. So all we have to do for the units is take these units from the beginning of the problem and just write them at the end of our number, right? So this is this many seconds, okay? Well, now we got to check for sig figs. So anytime you're doing dimensional analysis, what you're really doing is multiplying and dividing. And if you remember, the rule for multiplying and dividing is you're allowed to keep as many sig figs as the input with the fewest sig figs, okay? The fewest sig figs. So if we look through all of our inputs here, this number 12 has 2 sig figs, right, because they're both not zeros. 3 sig figs here, 2 sig figs here, only 1 sig fig here because this trailing 0 has no decimal, right? Only 1 sig fig here. These are all 1 sig fig here. And so really our answer is only allowed to keep 1 sig fig. Okay, after all that, only 1 sig fig. So remember, to round our answer with the proper number of sig figs, we go to, since we can only keep 1 sig fig, we're going to go to this first sig fig here, at 3, and round the number. So the 7 does round the 3 up because it's 5 or greater. So that 3 becomes a 4. And then what happens to all these other numbers here? Remember, they're in front of the decimal, right? They're numbers in front of the decimal that we're rounding. And so they turn into zeros. They don't just disappear, okay? They go to 0. Because if they just disappeared, we get 4 seconds for our answer. And we know that there's more than 4 seconds in 12 years. And that's a crazy answer, right? So remember when you're rounding, if it's a number in front of the decimal, it turns into a 0. It doesn't disappear. So this is going to be 4, 0, 0, 0, 0, 0, 0, 0, 0 seconds. Okay, so 400 million seconds in 1 year with the proper number of sig figs. That's a lot of seconds. Okay, but it's pretty cool. You can calculate that yourself now. Let's do another kind of problem here. And just real quick, guys, on that last number, on the last answer, I rounded it to 1 sig fig because of the sig fig rules, and I just want to do that as an example. The real rule is, we'll talk more about this later, but you only do sig figs when you have measured quantities in your answer, and none of those numbers in that problem were measured. They were defined. In other words, we didn't measure 365 days in a year. Someone says there's exactly 365 days in a year. So defined quantities actually have infinity sig figs. They just have as many sig figs as you want. The only ones that really have to worry about sig figs are measured quantities. I just wanted to practice sig fig rounding on that last question. That's why I did it. But in reality, the only time you worry about sig figs is when your problem has some measured quantities in it. Okay, meaning things we got from an instrument in the lab. So just keep that in mind. Okay, guys, so we have another question up here, up in the top. It says 35 miles per hour. That slash means per. So miles per hour is the way you'd write that. Equals question mark kilometers per second. Okay. So the first thing and the most important thing when you're doing the domino game, when you're doing dimensional analysis, is to set up the problem correctly. So don't skip through this real fast, because if you do this wrong, the whole problem will get messed up. So take your time, make sure you have it set up correctly before you move on to the next step. So we always start by writing down our starting domino, which is what we're looking for. Okay. Now this one's different from before because these dominoes have a top and a bottom. So I'll show you what that looks like. We're looking for here question mark kilometers per second, right? So I'm going to write that down like a domino with the question mark kilometers. And the per, anything under the per after the slash goes on the bottom of the domino, okay? So it's kilometers per second. This domino here means the exact same thing as what it says up here in the top, or kilometers per second. They all mean the same thing, so that's a good thing to remember. All right, now I'm going to put my equal sign. And remember, the rule of the domino game for starting off is that the bottom of the starting domino has to match the bottom of the first domino you put, right? That's super important, okay? So we need to find a domino up here that has seconds in it somewhere. And it doesn't matter if it's on top or bottom because we can flip it over, right? So which of these dominoes has seconds in it? Well, we have 60 seconds in a minute, right? This one right here. Okay, so we're going to use that domino, but the seconds have to be on bottom because it has to match straight across the equal sign. So we just flip it over, right? So this first domino, I'm just going to draw this big long line all the way across the paper. The first domino is going to be 60 seconds on bottom here in 1 minute. Okay? And the key thing, guys, remember, when you're starting off is that the bottom unit here matches straight across with the bottom unit of the first domino. Okay? Very, very, very important. Now, the second stage of the game here all we have to do is find dominoes that match diagonally, right, down and across. So we need this unit up here to match down and across over here, okay? So when we're adding dominoes, after we started, when we're adding dominoes, it's down and across diagonally. So we need to find a domino that has minutes in it. We already used this domino here, so it's out of the pool. We can't use it again. And you should do that when you're doing these at the beginning. Just cross through the ones you've used, okay? So next domino is going to have minutes in the bottom. The only other one that has minutes in it is this guy up here. Again, the minutes are in the wrong spot, but it's okay because we can just flip it over, right? So when we put it in, we want to make sure that the minutes unit matches down and across, right? So we need to put 60 minutes on bottom. And the rest of that domino is 1 hour on top. Okay, I draw a line because I finished with that domino. So that one's done too. And we're going to keep adding dominoes down and across until we end up with kilometers on top. Okay, so the next one, I have hours on top. I need to have hours on bottom. So I need some domino that has hours in it. And if you look up here in my pool, I don't have any dominoes left that have hours in them. So you guys might be thinking we're stuck now, okay? But we're not stuck because there's actually one more domino hiding in this problem that we didn't see at the beginning, which is right here in the question, okay? You always have to use a domino from your question, always, at some point in the problem. And this one right here, 35 miles per hour, does have hours in it. So let me write that down as a domino real quick, like the other ones, okay? It's 35 miles per, and it's really per 1 hour, okay? So there's an invisible 1 underneath all of these dominoes, the ones that don't have a number on the bottom. There's a 1 there, okay? So this domino then can go into my problem, and if we look back over here, I need the hour unit to match down and across, okay? So I don't have to flip this domino. I can just write it in the way it is, the 1 hour on bottom, so it matches, and the 35 miles on top. And then draw a line because I finished that domino. So I've finished this one. I can X through it. Okay, so don't forget, you're always going to have to use a domino from your question. Always. That's never an exception to that rule. Okay, so keep that in mind. What might help you to do is when you're doing these problems at the beginning, is to write the thing from the question down as a domino on your paper before you start setting up the problem so you don't forget to use it. That can help you a lot when you're first starting off with dimensional analysis. Okay, so next one. We're not done adding yet. So we need miles to match down and across, and we have this domino here with miles in it. So it's going to be 1 mile on bottom is equal to 5,280 feet. Okay, draw a line. So we use that domino. The next one has to have feet on bottom, so it's going to be this one right here. So there are 3.3 feet in 1 meter. So I can X through that one. And I ran out of room here, but the last domino is going to have to be this one right here. And we're going to put it in right there with 1,000 meters on bottom. So I'll write it in like this, 1,000 meters per 1 kilometer. Okay, so I've got all my dominoes added, and I know I'm done because the top unit here, even though it's squished in on the side, this KM matches the top unit of what I was looking for. The whole domino doesn't match, but the top unit here matches the top unit over here, and that means I'm finished adding dominoes, right? So I'm finished adding. Now all I have to do is solve the question. I rewrote the question again just so it's clear, and I just want to, at this point, when you're doing these at the beginning, stop for a second and just look at your problem and see if you've got everything set up correctly. The awesome thing about this technique is that you can see right away if you're doing it right or wrong before you even get an answer. You can check yourself before you wreck yourself, okay? So let's go through and check all the things we need to check. First thing we need to check is, did we start correctly? And we start correctly when the bottom of my question mark domino matches the bottom of my first domino. If you don't do that, everything will be wrong. So stop and check that every time, okay? Bottoms match straight across. Good. Okay, then we check when we added dominoes, did we follow the rule? The rule is down and across, right? Minutes matches minutes. Hours matches hours. Miles matches miles. Feet match feet. Meters match meters. Everything matches perfectly down and across, and so we added every domino correctly. The last thing we check is, did we end in the right spot? Does the top of my last domino match the top of my question? And it does, okay? So everything's set up correctly. We are awesome, we're good to go. If you make any mistakes, go back and try to fix them before you go on to this next step, okay? It's super important, guys. Now, what do we do from here to get the answer? Just a little bit of math. So the first thing we're going to do is multiply all of these numbers across the top, okay? So we're going to get 1 times 1 times 5,280, and then times 1, right? So the top number is just going to be 5,280. Because 1 times 35, of course. So 5,280 times 35 is 184,800. Okay. Now we do the same thing to the bottom numbers. So we're going to multiply all these across the bottom. 60 times 60 times 1 times 1 times 3.3 times 1,000. You can skip the ones because anything times 1 is just the same number. So 60 times 60 times 3.3 times 1,000. Okay, so we get a pretty big number on bottom this time. We get 11,880. Okay. Oh, actually, sorry, it's 11,880,000. So there's 3 more zeros here. That's a really big number, okay? So we have our top number and our bottom number, and the last step here is just to divide the top number by the bottom number on your calculator. So you get 184,800 divided by 11,880,000, and you get 0.015555555555 blah 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 to infinity. Okay, so that's a number, but it's not an answer because it needs units and sig figs. The units, remember, are going to come from what we were looking for, kilometers per second. Okay, so my answer is going to be in kilometers per second, and then we got to check for sig figs. So the only thing that's going to limit your sig figs are measured quantities, and I want you guys to think about which of these numbers in here is something that we just know is true and something we actually measured in the problem. Let's go through and look at all of our dominoes real quick. So 60 seconds in a minute is not measured. That's something that we're told, so it doesn't matter. 60 minutes in an hour doesn't matter for sig figs. 35 miles an hour, though, is something that somebody measured from their speedometer or something. So this right here, 35 miles per hour, is going to limit the number of sig figs we can keep. Okay, so this number, 35 miles per hour, has 2 sig figs in it. This one doesn't count, it's infinity sig figs there too. So just the number from the question has 2 sig figs in it. So we're going to be limited to 2 sig figs. So let's go ahead and double check our answer over here. And good shortcut for that, by the way, guys, is the number from the question will be the one that limits your sig figs most of the time. Okay, so the number from our question had 2 sig figs in it, 35. So we can only keep 2 sig figs in our answer. So we go back to our answer over here, and we go to the second sig fig, which is these leading zeros are not significant, they don't count. So we go 1 and then 5, our second sig fig is right there. There's a 5 after the rounding place, that's going to round our other 5 up. So I'm just going to write it up here on top. Our answer is going to be 0.016, because the 5 rounded us up. Now all those other numbers go away, because they're after the decimal, they don't turn into zeros, they just go away. Then we put the units, which is going to be kilometers per second. Okay, so you can either write kilometers per second like this, or you could even put kilometers per second if you wanted to. I prefer the top way, though. It's a little bit easier to read. Okay, so we multiplied across the top and the bottom, divided those 2 numbers, and got our answer with the right units and the right number of sig figs. Cool, good to go. All right, guys, so you had 2 example problems there, and the only way for you to get good at this is to practice doing it over and over again. Okay, you have to practice dimensional analysis because we're going to use it a lot this year, and it's going to be a big part of your first exam. So I'm giving you guys lots of time in class to practice this. You have to make sure that you're doing all the right things in the right order, getting the steps down correctly. And if you're having trouble with any of it, please let me know, okay? There's also going to be some of these on the Quest homework for the week that is important, super important practice before that first exam. So Practice makes perfect, guys. Do it over and over again, and you will get good at this. And if you're good at this now, it's going to make your life a whole lot easier this year, I promise. So please come to tutoring if you need it. Stay after school. I'm here in the mornings. Take time in class. Ask other people in class to help you with it. But make sure you can do this. I know you guys can do it. You guys are all super smart, and you can do this stuff. It's not really that hard once you get the hang of it. Just takes practice. That's it. So good luck, guys, on the practice stuff, and I hope you do well on the quiz.